So in this unit, we're going to use two different terms. We're going to use the term temperature and we're going to use the term heat. And it's really important that you don't get these two things confused. Okay? Temperature is a measure of how hot or cold something is. We usually ask for the temperature as we want to know if something's hot or cold, or if it's going to be hot today or cold today. But really, it's a measure of the kinetic energy. And remember, kinetic energy is the energy of moving. I know this was from way back in the beginning of the year, but it'll help remind you. And then basically, if the temperature changes, that means we're transferring energy. Okay, you can see this person has one of these little heat blocks and it turns a different color where his hand is. And this is because he's transferring energy basically to this little block. Okay. So now we can talk about thermal energy and temperature as well. Okay, so thermal energy is the total energy of the molecules in a sample, and it is proportional to the number of particles in a sample. Okay, that means if a sample is bigger, it's going to have more thermal energy. Okay, it's possible that you could have a small cup of hot chocolate or a large lake, and the lake could have more thermal energy than the small cup of hot chocolate just because the lake is so big. But then when you talk about temperature, it has no relationship on the size. Okay, so size does not matter for temperature. Okay, if you have a small cup of hot chocolate or a lake, the hot chocolate is going to have a hotter temperature regardless of how big the lake is. It does not matter. So make sure you don't get these two confused. Now, if something is moving, it has kinetic energy. We know this. We know that kinetic energy is the energy of moving. And that means that atoms and molecules have kinetic energy because they are always moving. Okay, and I'll write that in. This means if something has a higher temperature, it's going to have a higher kinetic energy. And then we can talk about the thermal energy. Again, that thermal energy is the total kinetic energy of a substance. So when you go from a solid to a liquid to a gas and then to a plasma, you're adding heat the whole time. Okay? And so a solid has less kinetic energy than a gas. A liquid has less kinetic energy than a gas, but more than a solid. And so by finding out what phase the substance is in, you can see, you can compare relative kinetic energy. So let's just kind of like go ahead and make a rule. The average kinetic energy of a hot thing is going to be more than the average kinetic energy of the cold thing. And so what they're trying to show you in this yellow box is that they're showing you that these arrows are longer, so they're saying that these are moving faster because it's hot. And in this one, they're moving slower because it's cold.